Hello everybody, I'm Marcin Ziombek, Deshan, and today I want to show you probably the biggest electric project in Survivalcraft. Yes, it's my PC. But first of all, I'm really sorry for bad video and sound quality. I have very poor camera device, and my actual tablet Nexus 7 2012 has an NVIDIA Tegra 3 processor which don't allow me to capture the screen on Android. So once again, sorry for bad quality. I will try use simple words, simple phrases to describe all things in this video, and let's start here in the operator's room. As you can see, there are many interesting things. Probably the most important one is instruction. Click restart and wait for communicate about running. Here you have restart button, which you have to click to start this PC. You have to wait about 13 seconds, I think, to clear all data in RAM banks. On the left, we have status diodes, which are describing the status of any part in the CPU. So, if this diode is blinking, this means that CPU is running. In the same way, are running diode for GPU, RAM and HDD. On the right, we have a keyboard. The first 10 buttons are numbers, as you can see in that side. And the last two have special meaning. One of the top is OK, it's confirmation button, and one of the bottom is no, it's cancel button. We have also arrow keys, which can be used to move the pointer in the game. Okay, that's everything in operator's room. Let's show how it works. Here we have very simple demultiplexer, which converts signal from PC status wire into 4 wires connected to the diodes. I decided that the first bit in this wire has describing CPU status. Second, GPU, third, RAM and fourth, HDD. This wire isn't connected to the PC, but I made very simple circuit to simulate this functionality. Okay, I start the simulation. Let's fly to operator's room, and look, it works. The next one is keyboard. Keyboard is converting information from 16 cables into only 2. First wire is click action. In this wire, signal is in this wire when you click any button in operator's room. And the second wire is key code. In this cable will be the code of the key you clicked. So, for example, every number has the same key code. But there are many special buttons like OK, which have code 10, cancel button which has code 11, and of course arrow keys. Left, down, right and up. Right has code 15, etc. This keyboard also isn't connected to the PC. I want to do this in the near future. Let's see probably the biggest part of this PC, the screen. The screen is very huge, as you can see. It allows us to display 2056 pixels, so it's resolution 16 by 16 pixels when you use 4 pixels block, or 8 by 8 pixel screen when we use single pixel block. I decided to use the single pixel block, so this screen will be 8 by 8 pixel. Why? Because to every pixel I have a wire which can store 4-bit information. Every 4-bit information can be used to reproduce the color. For example, black, white, red, green, blue, magenta, cyan, yellow, and dark version of these ones. So dark red, dark yellow, gray, etc. And I think we can do more using 8 by 8 pixel screen than 16 by 16 pixel, but only black and white. I think Calus should add color pixels to allow me end this screen. We have also screen which can show us numbers from 0 to 99 and some special numbers in hexadecimal system. This screen is connected to the PC by 4 wires. Oh, here we go. GPU cat set, GPU SY, GPU value, and GPU SX. GPU SX and SY is describing position, wire get or set, meaning that we want to change or only get the information about pixel, and GPU value store data value for this pixel. We have also 2 wires for number display. Okay, that's all about the screen. Let's see how look the most important part of this PC, the program sector. Here we have a lot of memory banks which can store program information. So let's start with instruction type and instruction comment. These 2 banks have information about instructions we want to use. This PC is divided into many sectors, and every sector is one of the instruction type. So we have following sectors: logic sector, simple math sector, bit shifting, math, comparison, storage and time, GPU, it's pretty long, input, stack and heap, and sound card sector. The 2 last aren't built yet. And in every sector we have a lot of instruction we can use. For example, in storage and time sectors we have HDD save and read, and RAM save and read. And at the top you have RAM, wait, and text instructions. Okay, let's see next memory banks. It's argument A, position bits from 0 to 3 and 4 to 7, and in the same way for argument B and result. Well, this CPU has a very big register. Register is something like fast RAM, fast memory. In this CPU, our register has 2056 numbers. Every number is 8-bit. So, these memory banks are describing which two arguments from any position in register we want to use, we want to combine in any instruction. For example, we can add two numbers, and where we want to save the result. We can also save in any position in the register. Sometimes we want to use only numbers, normal number, for example 5. We want to add number 5 to any we want to add number 5, for example, to register B1, and then we use register constant mode. Okay, so for every line of code we have instruction type, instruction command, positions for arguments, and result, and of course constant mode. Information about code lines are stored in these 4 memory banks, and we have two versions, positive and negative. Every positive and negative counter has describing bits positions from 0 to 3 and 4 to 7. Why? Why we have positive and negative counters? So, it allows us to use something like conditioning. So we have in our code we can write if instruction, which allow to change line of code immediately. So we can skip many instructions or go back. Okay, it's very complicated. I really can't describe it in simple words, so I'm sorry. Here we have 4 wires which we can use to control all PC, and here we have CPU clock, load and save wire, tick in and tick out. These 4 wires will be connected to the clock clock sector in this PC. Okay, go next to the linkers part, and this linker part is converting information from these cables into another cables. Yeah. So we have instruction type, instruction command, load and save, register position from these memory banks, register constant mode, and tick in and tick out. Okay, so many cables, and here we have instruction type and command, input A, input B, and result into versions bits from 0 to 3 and 4 to 7, and at the end tick out. Tick out wire is very interesting because in this wire will be electricity, will be signal when this CPU will end the whole job, the whole evaluating. Okay. Here we have the registers. Here is register B high, which means it that it's register for argument B bits from 4 to 7, and in the same way we have here register B low 4 bits from 0 to 3 here. Okay, we have 4 registers. Let's go to describe sectors. Every sector give us a lot of instructions we can use in our programs. So logic sector give us not instruction, and, or, and XOR, exclusive OR. Simple math, increment by 16, decrement and decrement by 16. Shifting bits, shift bits right, shift right 4 bits, shift left by 4 bits, and copy the argument. Next is math, we can add two numbers, subtract, multiply, division, modular division, convert numbers, and get random number. I have to say you that we can multiplying only 8-bit numbers for 4-bit number by 4-bit number, and in the same way we can division and modular division only 4-bit numbers. The bits from 4 to 7 are ignored in these instructions. Also very interesting are these instructions converting between number systems. Why? Every CPU, every computer is using the binary system, which is totally understandable for us, for people. So, for example, when we want to show the result in high scores, we have to convert number from binary system to decimal system. And in the same way, when we want to make simple calculator, then we must convert number from decimal system, which is from a user, to binary system, because we want to simplify any operation in this PC. Okay. Next is comparison sector, which give us following operations: equal, not equal, bigger than, and equal or bigger than. They will be very common in if instruction, if conditions. Next we have storage and time. So as I said before, HDD and RAM save and read. Getting time from Survivalcraft time manager. Wait for next synchronization tick. This instruction will be used for games, and showing the text. This PC allows us to use only 15 text in any program. The first text, which is 16, is describing version of this map, and any next is for you. You can say by them, oh, this PC is just running. You can say, oh, congratulations, you get high score. Or you can show the simple menu in this PC. So, very, very interesting instruction. The last thing I want to say about this sector is that HDD and RAM is pretty the same. They are very, very fast, and the only difference between them is that I want to clear the RAM register, the RAM memory in every PC start. Okay, go next. We have GPU. GPU is very simply when we want to have only 1 pixel blocks, it has 7 display instructions which can be used to change the number on the screen and get or set pixel. Okay, go next. Next we have input, stack and keep sector. Input instruction will be used to connect this keyboard to PC, and stack and heap. If you are learning IT, you will know that stack and heap are very nice when you're programming games. For example, Snake. And the last one is sound card. I also want to simplify sound card like GPU, probably to only one sound in any note in one octave. Why? Because from sound card I have to make the cables to the operator's room, 3 cables, and as you can see, near the operator's room we haven't enough space to make a lot of sound devices. Okay. Oh, I just forgot about one thing about this screen. So, when we want to use 4x4 pixel blocks, we can refresh, update only 2 or 3 pixels per second, and this screen will have about 2050 pixels. It's about 1% of the area of the screen. So when we want to change all screen, it will take about 100 seconds, about 2 minutes. It's a lot of. In the same way, when we use a single pixel block but with color, we can change about 5 or 6 pixels per second, which is about 6% of the area, and wow, this is pretty fast. The biggest update for electric will be done when Calus will increase the update speed to the of electric. Actually, it's about 15 times per second, and this allows me to make this CPU with about 4-5 Hertz, and I really want to increase this number, so maybe something like 200 electric updates per second will be pretty nice. And of course, lower numbers also can be very useful. For example, only 2 updates per second can be used to debug any electric devices while projecting them. So, Calus, please make an option to change electric refresh from, for example, 1 to 200 updates per second, please. I also write at the forum about possibly games which can be made for this CPU. These are Pong, Arkanoid, Cars, Tic-Tac-Toe, and etc. Very interesting games. And I think Survivalcraft is created for making games, making huge electric devices, and things like this one will increase popularity of this game. So probably that's everything I want to say you today. um, when if you have any ideas about this PC, please write to me on the forum. I really wait for your comment, and thanks for watching. Bye bye.